Afternoon, everybody. You're in the Milano room under the Web Apps track. This is Chris Ang and Brandon Creighton giving a presentation on Deconstructing ColdFusion. Please give them a good hand.
Thank you. Hi, everybody. We'll be talking about ColdFusion today. Just quick show of hands. Who here has done any development or pen testing or code review of a ColdFusion application? Okay, good. We can dispense with some of the background information probably. Just at a high level, this talk is really not to bash Adobe. There's no 0 days. There's no really flashy substance here about vulnerabilities in the platform itself. What we're really trying to do is provide a practical talk that gives you information that you can go back and use in your jobs, whether you're a developer or a code reviewer or a pen tester, things that you can actually go back and look for or do to improve the security of your applications. We'll also provide some background about how ColdFusion actually works underneath the covers, what the underlying Java classes look like, and some of the request processing, variable scoping, and a lot of the information about just how ColdFusion works underneath the ColdFusion markup layer. Very quickly, our bios. My name is Chris Ang. I'm the Senior Director of Research at Veracode. Veracode is a software security analysis company. We do software analysis in the cloud, and my job at Veracode is to run the team that defines all the requirements and information for how we look for vulnerabilities in different languages and different frameworks and so on. And I'm here with Brandon Creighton, who's one of the researchers on my team, who's done a lot of the ColdFusion work and various other platforms. Our agenda today is we're going to start out by talking about the platform. What's the background of ColdFusion? Where did it come from? How has it evolved over the years? It's actually a very old development platform with a lot of history and several companies behind it. We'll then go into the platform architecture and talk about the ColdFusion markup language a little bit and describe how ColdFusion pages are processed and the different parts of a ColdFusion page and components and the building blocks, basically. And then we'll have a section covering a bunch of different practical tips for practitioners and developers, which is the at home or in your jobs. And then finally, at the end of the talk, we'll be doing ColdFusion behind the curtain, which gets into what does ColdFusion look like when it's compiled down to Java. And we'll look at some of the ugliness that happens when you do that and what the resulting classes look like when you compile it down. And then we'll also have a little tool to provide at the end of it, which will help reverse engineers ColdFusion applications. Okay, so the background. Well, like I said, this is a really old platform. ColdFusion was originally developed in 1995 by a company called Alaire in Massachusetts. And if you think back to 1995, there really was not a whole lot of web application going on at the time. Most websites at the time were static. They were HTML. There were maybe some CGI scripts or very small Perl scripts or things that did simple tasks, but not full-fledged web applications. So the idea at the time was make it easier for people who are writing HTML to do real things with their websites. And the first thing that they wanted to enable was connecting simple HTML pages to a database. But they didn't want to do it in such a way that required somebody with programming expertise to build these applications. So they designed something that looks like HTML, but had some additional tags that would enable this functionality. And that way you could take these web designers or people that could just code up basic HTML without necessarily having any programming background, and they could start to write web applications that did things. So from the very beginning, it's designed for an audience that is not developers, and that's a theme that will play out, more and more as we get into the different topics that we'll cover later. Initially, when it was released in version 1.0, it was Windows only. It had its built-in web server. It was a custom web server, and it was very simple. It didn't do very much. Fast forward 7 years to ColdFusion 6 in 2002, and what they did here is they transitioned from a custom web server and custom everything to J2EE. So J2EE was becoming popular around this time, and they said, well, let's make ColdFusion J2EE compliant, and that way you could write an application and you could deploy it anywhere, whether it's WebLogic or WebSphere or ATG Dynamo at the time, or whatever the J2EE server was, and so it makes it a little bit more portable to different servers. So with ColdFusion 6, everything got compiled to Java classes before it was run. Apps could be bundled up as wars or ears, just like any other J2EE application. You could bundle up the admin interface and other pieces that come with the ColdFusion runtime. And ColdFusion 6 was bundled with JRun, which was the J2EE server that Alaire, actually it was Macromedia by this time, that they had also purchased through a different acquisition. So they were kind of bundling all these products together. And now if you fast forward another 7 years, ColdFusion 9, which is the latest version, was released in 2009. Of course, it's Adobe now, and the recent versions since ColdFusion 6 have focused mostly on integration with other Adobe technologies and some other Microsoft technologies, but basically interoperability layers to make it just more powerful and you make it able to connect with other pieces of the infrastructure. Historical vulnerabilities, we won't spend a whole lot of time here, but just to give you a big picture of what ColdFusion has faced in the past. Just about every type of vulnerability has been found over the years in ColdFusion. I mean, it's 15 years old. It's had plenty of time to get attacked. In the earlier versions, prior to ColdFusion 6, when it was the Alaire Macromedia days, you had arbitrary file retrieval. There was some pretty ugly stuff with XOR encrypting passwords. Every J2EE server pretty much had predictable session identifiers, and ColdFusion was no exception to that. And there have been recent vulnerabilities as well. Within the past 12 months, just if you go and search the National Vulnerability Database, you can find ColdFusion vulnerabilities. Most of them are cross-site scripting vulnerabilities these days. And I found a couple that were filed in May 2010. So this is still something that's being actively attacked, and people are still finding issues in this platform. This is a question that I get quite a bit when I mention to somebody that I'm talking about ColdFusion. And I say, well, does anybody actually use that anymore? And that was a good question because these days, if you're developing a new application, especially if you're in an enterprise, you're probably picking J2EE, you're picking ASP.NET. Those are the most popular platforms today. But if you just go and search Google for file extensions to give you kind of a rough cut of who's using ColdFusion, you can see that the numbers are still relatively high. ASPX would be an ASP.NET page, and we found 1.2 billion of those, and we found roughly a third of that number of ColdFusion pages. So it's still fairly prevalent. Now, it's not anywhere nearly as prevalent as PHP pages, obviously looking at the numbers there, but you can see it's still there. It's still in the top 4 or 5. And this Google search was done a couple months ago, but I doubt it's changed too much in that time. If you look at Adobe's website, they cite that there are 770,000 ColdFusion developers, 12,000 companies, and 125,000 ColdFusion servers. And I just picked some of the logos of the companies that were listed on there just to kind of give you a feel for, these are some pretty big companies using ColdFusion still today for some of their marquee applications. And then this is a graph that came from a recent report from Blackhat that one of their security statistics reports that they release every quarter. And they release this chart that shows how different verticals use different web application platforms. So the boxes in gray that I have outlined in orange are the ColdFusion chunks. And you can see that the ColdFusion is most prevalent in education, healthcare, and retail, according to Blackhat. Anecdotally, we know that ColdFusion is also very popular in the government space. And I asked Whitehat about this, why isn't government represented here? They actually had said they took some of that data out because for probably some contractual reasons, but they explicitly took out the government data, so that's why it's not reflected here. If it were here, I expect it would probably be somewhere between 20 and 30% as well, just based on what we've seen in the field. And then finally, before we start to get into the building blocks of ColdFusion, why did we do this talk? We were developing ColdFusion support for our binary analysis service at the request of some customers. So we had to go through our process of figuring out how ColdFusion works, looking at the attack surface, figuring out what common coding patterns people would do that would create the typical types of web application vulnerabilities. So we had to do this research in order to get our product to support ColdFusion analysis. And as we were doing that, as we were looking in the literature to figure out how these things worked, we found that there were not really that many resources available on securing ColdFusion apps or testing ColdFusion apps. There were little islands of information here and there. Adobe had several documents that covered ColdFusion. One was specifically dedicated to security. It was a ColdFusion 8 security guidelines. But when we looked at it, it was mostly information on security features, authentication, kind of best practices, and here's how to use these different features, but very little information on common mistakes that people make or pitfalls to watch out for, or comparisons between coding good code and bad code. Similarly, there's a securing applications section in the ColdFusion 9 developer guide, which is over 1,000 pages, but it's about the same information. There was an OWASP project started for ColdFusion in May 2009, and it had a few check-ins, and then it got abandoned. So there wasn't really anything to take from there. And then every other presentation we've seen in security conferences or other places that covered ColdFusion security, we're looking at the infrastructure footprint, specifically which ports are open, how do I minimize the attack surface of ColdFusion, but not a whole lot of information on the applications themselves, right? So it was like, well, you can attack the admin server this way, or you can attack the RDS server, or different components that get shipped with ColdFusion, but they wouldn't talk very much at the code level. So that's what we saw out there, and so that's why we felt the need to put together this talk. So Brandon's going to go over the basics of platform architecture, and then we'll get into the code samples.
So a lot of you, we did a show of hands earlier, a lot of you know a lot of this, so I'll skip through it pretty quickly. But ColdFusion is mostly comprised of pages and components. Both of these are HTML-styled markup files. They're similar to, it's similar to traditional ASP and PHP and syntax, sort of, except that it's a little bit, they tried to make, in the earlier stages of ColdFusion, they tried to make as much as possible done using HTML-style tags. So if you want to open a file and read lines from it and output them from that, there's a tag to open the file, there's a tag to loop it over, and there's a tag, there's a way to interpolate that data into your output. The difference between pages and components is that pages are usually the main entry points. They end in CFM, and they basically just they are interpreted, except for the ColdFusion specific tags, they're just output directly out to the response. And the ColdFusion tags are evaluated, and that's how it works. Components usually contain usable functions that other people can incorporate into it, and you can call component functions from other pages or other components. And it's basically just a way to reuse code through an application. Functions, or AKA UDFs, user-defined functions, it's a traditional function. You can call them remotely. One interesting thing about these about functions is that as of, I don't know when it started. I think it was around CF6 or CF7. Functions, they allow the ability for functions to be called externally if there's an access modifier you specify in the CF function tag. And if that's specified, then you can invoke any function with arbitrary arguments derived directly from the request string from anywhere, as long as you can access it, as long as the web server lets you through, if you've specified that as public. A lot of people use this, and it was designed to implement web services pretty easily, really simple, quick and dirty things. But there's no authentication directly built in, so a lot of people end up rolling their own. That's one thing to watch out for. I'll talk a little bit about the kind of the internal workings of the life cycle of the request, which is all of the stages that it goes through and kind of what happens at each stage. When you request a page, say foo.cfm, it actually looks, before it actually runs that, it looks for one of two files. One of them is application.cfc or application.cfm. And that's basically if you want to run code that is going to be run before any given page, any given request, that stuff gets loaded. So if you want to have setup stuff that's common to the rest of an application, that's where you put it. And application.cfm is a page. It's simple. It just runs before everything, and that's pretty much it. Application.cfc lets you define certain entry points. I don't know if it's on this slide or not. But basically, you can say, when the request starts, run this code. You can have separate functions for these. When a session starts, when the application starts, when the server starts, you can have it run separate things for that. So it gives you developers a little bit more flexibility in terms of what they're doing. And here's a list of those. One of them at the end is on error, and when an internal ColdFusion exception occurs, and it's not being caught, and there's no explicit error handling in the form of a CF error tag, this function is called if it exists. And if it doesn't, then it goes to a default error page. Pages can include other pages. There are a few different ways to do this. One of them is to use a tag called cfinclude, and that one, the difference between that and the other another option, which is calling it as a custom tag, which is you literally prefix the name of the file modulos.cfm with cf underscore, and you call it like that. So if you can see cf underscore foo, you just write that in your code, and it looks for a file called foo.cfm and runs it. Yeah. Oh, and there's like I was talking, or like Chris was mentioning earlier, there are tags for interacting with a lot of stuff. Like you want to run LDAP queries, well, ColdFusion can make that happen. Do you want to talk to a Flash applet or a Flash application? You can definitely do that. There are lots of ways to do that. Sending mail, FTPing, pretty much anything you can imagine that that was common when ColdFusion was started is in there, as well as stuff that's been added over the years. So they've added a lot to it. Okay, so now I guess we're getting into the language of or more of the semantics of the actual language. And it's, ColdFusion has variables, and ColdFusion has variables, big surprise. They are dynamically scoped and dynamically typed. In documentation, you'll see referred to as scopes, and that's slightly confusing if you're in a kind of very explicit anal retentive programming language design sense, because they're not really scopes, but they are. So anyway, you can explicitly, so when you refer to a variable, when you reference a variable within, say, a tag that's directed to output it, which is CF output, or in other tags which you can use variables in. And that's, by the way, that's the syntax for interpolating a variable. You don't have to explicitly refer to a variable within its given scope. In the case of the top one, there's no scope preceding it. And the one at the bottom, it's looking in the URL scope. And the URL scope is get variables, essentially. That's where if you want to explicitly refer to a get variable, you use url.foo. Now, if you don't use qualified variable, or if you don't use fully qualified variables, if you just use variables named foo or I or x, being able to tell exactly what you're going to get just by looking at it can be kind of tricky. You kind of have to know, for example, in the case of CF query, it imports, if you select rows from a database, the names of the result rows, those names get imported into the local variable scope, and you can just refer to them through there. And there's no real explicit place for this other than in the query. And this even happens in the case of some stored procedures on some platforms. So you can basically just get random variables in code, and unless you're familiar with the underlying workings of it, it can be hard to tell what the developer was intending. So here's a list of all of the different variable scopes. And I'm not going to go through all of these. There's the typical ones are here. A way to get variables, where to get the post variables, cookies, files. There's session data, which you can read and write to. There's application data. There's request, which is not like request in PHP. It's designed, if you have it's designed for or local storage over the lifetime of an entire request. So if you have a whole mess of pages calling each other and components and all sorts of stuff, and you need to share data between them, that's a really easy and pretty lazy way to do it. So it gets used for that a lot. In addition to session, there's also client scoping. The client scope, which it's also keyed to a given client, given HTTP client by a cookie. But also sometimes the data can be stored in the cookie as well. It's sort of similar to well, no, it's not really similar to ASP.NET form type, but basically sometimes it can be the data is in the client scope is supplied by the client itself, by the HTTP client, and sometimes it's stored on the server. So it's not like session data explicitly. As I mentioned earlier, CF is dynamically typed and it's weakly typed. The variable type system really hasn't changed since it was designed to be easy in the 90s. And it's pretty common to see implicit conversions from different types all over the place. And you don't really even think about types in general when you're writing ColdFusion, unless you're dealing with something like a query or an array or a file, or a few other similar things, and I'll go over some of those later. Pretty much everything, you just use it and it works. And the way it works under the covers is there are a lot of implicit conversions that say, well, you're calling a function or a tag that needs a number. Okay. If a variable you pass in is a string, it's going to implicitly try to convert it to a number. And if it works, great. If not, well, then it'll throw an exception and something will happen. Some of the types that aren't like this are the opaque types, which are like queries, files, HTTP queries, LDAP queries, files, all sorts of other things. And the way these work is they look like variables, except you can access them like structures. Like, say, you have a file named X, you can use X, or a query result named X, you can use X dot column 1 or whatever to access the name of them. And instead of, and obviously, like, this isn't always great for developers, and they need to have their own enforcement of type checking. And the way that usually works is there are two ways this is kind of built into the language. One of them is through the tag named cfparam, and that basically says, I'm explicitly declaring a variable, which isn't necessary at all, and and you can optionally say, I want it to be of this type. And what they mean by type isn't necessarily like there's an underlying language type. It means that can this be converted to it, which is fine. So if you say, I want it to be of type telephone, it'll try to parse that as a US NANPA phone number, so like 10 digits optionally formatted with dashes. And if it doesn't, then it throws an exception. And they have all sorts of things for this. There's a Boolean one, there's a credit card one, there's various date ones, times. There's a social security number one. Basically just to make it as easy as possible for people to just input whatever and not have to think too hard about things. Although a lot of those tags done by CF_param and CF_argument work like that, there are some that do explicitly check for types, and those are array, query, struct, and string, which is basically anything that's not one of those can be converted to a string. And the difference between CF_param and CF_argument is that CF_param effectively refers to a given variable binding at a given point in time and says, this has to be this, and CF_argument checks it as an argument to a function. As I mentioned earlier, this is how you interpolate data. A lot of you probably know a lot about how this works. It's pretty simple. If you've ever written a dynamic application, you've dealt with stuff like this. ColdFusion does have some pretty interesting features. There's eval. There's two different forms of eval. There's a IIF, which is kind of similar. It's a conditional evaluation or conditional delayed evaluation. It also lets you define, in an assignment, you can say, well, the variable name to be assigned to is also dynamically specified. I guess I'll turn it over to Chris for some more.
Okay, so we're going to start going through things that you would do as a developer or a code reviewer or a pen tester if you're looking at one of these applications and you want to find stuff that's wrong with it. So the first thing you have to understand, usually when you're looking for typical web application vulnerabilities, is where does the untrusted data come from, right? Because usually you're looking for untrusted data, you're following it through the program and looking for it to be used in a dangerous way, whether that's a SQL query or printing something out to a page or going into some API that's dangerous. But you have to start by understanding where the data comes from. So one thing you can do is you can look for data by scopes. We had the list of scopes earlier. So URL.anything means a variable that was passed in through the query string in the browser. Form.anything was passed in the post data of an HTTP request. Cookie is probably pretty obvious. Flash comes from the Flash movie. CGI, not all of the CGI scope variables are tainted, but most of them either are tainted by default or can be easily tainted. And we'll have a slide on that later. And then some of the scopes are going to be tainted depending on how the application was written. So we talked about session scope variables or request scope. And those can be entirely clean. So the session scope could be entirely clean or could be entirely dirty, depending on what the application developer did. They may use the session scope as a place to put stuff. They may copy every URL variable, for example, into the session scope. That's a bad idea, but they may do it. So you have to look at each one of these individually to see if it's tainted. Client.anything. This is another case where you have to look at how the application is configured. So if they're using cookies, then obviously anything in the client scope is going to be tainted because cookies themselves are tainted. But if they're using a different mechanism for the client scope, such as using the registry on the server side, then those are not going to be tainted because the end user of the application can't go and control the registry. And then finally, arguments to CF functions, which are defined with access remote. Brandon was talking about that earlier, where you could access CF functions without authentication, just using the URL and a special syntax for doing so. If the access is set to remote for that CF function, then you have to consider all the arguments to be tainted. So this is a relatively complete list of all the places where you would look for untrusted data in entering a ColdFusion application. And that's kind of as good of a starting point as any when you're looking for these types of vulnerabilities. So keep that in mind. We have a few slides on cross-site scripting because cross-site scripting in ColdFusion is very complicated and kind of a side effect of the design being simplified for non-developers is that you have a lot of mechanisms built in that do similar things, but they don't do it completely, or they overlap in certain ways, and nothing actually provides a full defense against cross-site scripting. So there are a few different suggestions that are made in the developer documentation to help protect against cross-site scripting. And one of these is this attribute they have called script protect. And this is something that can be set up at the application level. We have some example code there. So you CF application script protect equals all, and that will just say turn on this script protect mechanism for the whole application. And the way script protect is described in the documentation is it says it will block most attempts of cross-site scripting. And there's not a whole lot of information beyond that. What it actually does is it looks for a script. It looks for the literal open bracket script in user-provided data. And if it sees open bracket script, it will replace it with open bracket invalid tag. So that way, if you're injecting that type of cross-site scripting attack, such as just script alert foo, ColdFusion server is going to see that, and it's going to replace that open bracket script with open bracket invalid tag. And obviously, when the browser renders that, you don't have matching script tags, and the alert is not going to actually execute. So nothing will happen. And script protect looks for script, it looks for object, it looks for a couple others. I think there are two others, but basically it's doing the same thing. It's looking for those special tags and it's replacing them with invalid tag. And this is supposed to protect against most instances of cross-site scripting, which is a complete misnomer because it's absolutely trivial to circumvent. For example, if you take that same vulnerable code that we did earlier that says you typed url.foo, and so obviously you just pass in something on the query string and it gets printed out to the page. Well, instead of using a script tag, just use an image tag. Image isn't blacklisted, so it happily passes straight through script protect and it loads that image there that's in the source tag, and as soon as it's done loading the image, it'll run alert foo. And this is just one of many examples. Because it's a blacklist, you could use basically any tag that accepts an attribute that can contain JavaScript. So this is really, really easy to circumvent, yet it's touted as this major defense. You can mess with the blacklist if you want. You can go into this XML file that is packaged with the ColdFusion war, and it's called neo-security. And it's regex syntax, and it shows you exactly what it's looking for and what it replaces stuff with. But at the end of the day, it's still a blacklist, and a blacklist is not the right way to protect against cross-site scripting. So bottom line is, script protect doesn't hurt you, but it really doesn't help you that much either. So like most programming languages, ColdFusion gives you a few APIs that you can use to do HTML encoding. And the two that they give you are HTML edit format and HTML code format. And those take the input that's given to them, and they replace open and close bracket, double quote, and ampersand with the HTML entity equivalents, which will prevent some cross-site scripting attacks from succeeding. However, they don't encode single quotes, and for any attributes that are unquoted or single quoted, or something that's already within a script block, it's not going to help you. If you are familiar with the OWASP XSS prevention cheat sheet, you know that encoding has to be done on a contextual basis. You have to look at where the data is being used in the context of the page and encode it depending on whether it's in a tag or it's in an attribute or a script section or a URL, and you have to apply the right type of encoding. And here we have kind of a one-size-fits-all solution. They say use HTML edit format, and it will encode those characters, and that's it. There are 4 examples of cases where you might use HTML edit format and it would not protect you at all, because there are either no double quotes to escape from, or you don't have to worry about brackets or anything like that to get the attack to actually execute. There's another API that they have called XML format. And it's the same as HTML edit format, except it also encodes single quotes. So now you get encoding of 5 characters instead of 4. So XML format is actually better than HTML edit format in just about every situation for protecting against cross-site scripting. But it's still not a complete one-size-fits-all, because you have to worry about situations where you're printing the output to an area of the page that's already in a JavaScript block. So again, it needs to be a contextual approach. There aren't really any other encoding functions that are suggested to be used here, at least provided by the framework. So you have to write your own. And generally, XML format is going to be better to use than HTML edit format. But the way it's named is so misleading, because the developer, so if somebody is not familiar with security or doesn't really understand what's going on, they're not very likely to use a function called XML format when they're writing an HTML page. Even though it's going to be better, it's going to encode more characters, a developer who's not kind of security aware is going to be less likely to use it. So it's a little misleading in that sense as well. So let's say you've gone to some security awareness, security development training, and you learned all about how blacklists are bad and whitelists are good, and you should always whitelist your input to make sure that your application is getting what it expects. And you have some code, like one of these ColdFusion expressions. The first one, for example, let's look at CF output. And you're passing a parameter in the query string called count, and it's supposed to contain a number. So you're taking all this, all this knowledge that you've gained through the security course, and you say, well, I should whitelist this. I should make sure that this is an integer, because there's no reason this should ever contain a word or special characters or anything like that. So you use the int API call, which is essentially like a cast. And you cast URL.count to an integer. And you say, well, that's going to protect me if somebody puts words in there, if they put cross-site scripting string or anything that I don't expect. And those other two examples are similar, right? Number format is a ColdFusion expression that does essentially the same thing. Java cast, you can cast a variable to a Boolean in that case. But they're all examples of doing some kind of whitelist checks. Well, what happens if, in that first example, you provide the variable count and you put something in it that's not a number? You're going to get this default error page from ColdFusion that looks like the graphic on the page here. It's going to say the value foo, if I supplied the word foo on the query string, the value foo cannot be converted to a number. And there's some developer information there, verbose debugging information, and so on, to help you figure out what went wrong. The problem here is that, as you can see on the error page, you're actually printing out the value that couldn't be cast. So for count, if we just put in a cross-site scripting attack vector, then that is actually going to get printed out on the error page, and it's going to cause cross-site scripting. So it's ironic, because you tried to do this whitelist validation, and actually by doing so, you caused an exploitable scenario through this default error page. Now, it's worth noting that on the default error page, script protect is always enabled at the runtime, but we already saw how it's easy to bypass script protect, so it's almost not even worth mentioning that it's enabled. So you're trying to do the right thing, and you create an exploitable condition. And that's not documented anywhere. So let's say you don't use the default error page, because let's face it, most applications, by the time they reach production, maybe sometimes somebody has told them not to use a default error page, maybe not for security reasons, but just because there's so much information displayed there, and it doesn't look pretty, or whatever the case may be. So you can define an error handler page that takes over when an error happens. So there's a CF error tag that you can use, and it says, if an error occurs, call errorhandler.cfm instead. That way, you won't get the default error page. It'll just redirect you to errorhandler.cfm. And then that page has access to an object called error, which you can then use to print out information about what happened, but you can do so in a pretty way. However, when you do that, you can still make some mistakes. So like I said, you have an error object, and you can start printing out various members of that object that give you information on what went wrong. And one of those is error.diagnostics, and one of those is error.message. And both of those also contain the attack string. So if you have your custom error handler, you're not using the default error page, you define your custom error handler to avoid the problems with the default page. And on your custom, your pretty error handling page, you print out, sorry, you threw an error occurred, here's what happened, and then you output error.message. You've just caused cross-site scripting. Again, you can also use exception handling. So you can use typical try-catch blocks, similar to other languages that are out there. There are CF tags for that as well. And when you're in a CF catch block, you have access to an object called CF catch, and that also has different fields that you can print out what happened. And the CF catch.message field also contains the attack string. So if you're doing any of these things for error handling or exception handling, and you're not aware of which fields contain tainted information, you can end up still causing cross-site scripting to occur on the page. So ColdFusion is like fraught with all sorts of pitfalls that you can make with cross-site scripting. And as you saw, the defenses are incomplete, the documentation is incomplete, and no wonder it's so easy to find cross-site scripting when you're pen testing a ColdFusion application, because it's just not easy to protect against. Let's face it. I mean, there's just too much going on. We have a little bit on SQL injection, just because there is one behavior that I wanted to point out. We won't dwell too much on this, but this is an example of what a SQL query looks like in ColdFusion. They have a tag called CF query. You give it a name, you point it to a data source. The data source is configured on the back end in the server before the application even starts running. So you have a CF query tag, you tell it what to query against, you put the query in there, and then as you can see, you can use CF expressions inside the query tag to populate parts of the query. So page ID is populated by the variable called page ID. Title search is populated by the variable on the page called title search. And once those variables are populated, the query is then sent to the database and executed. So pretty self-explanatory. So you might think by looking at this that both page ID and title search are injectable. That for page ID, you could do a union select or put a semicolon or whatever, or for title search that you could put a single quote and escape out of that and then start to manipulate your query. In fact, ColdFusion actually has a mitigation against some of this stuff. Title search is actually not injectable. ColdFusion, if you're inside a query tag, a CF query tag, and you use any ColdFusion expression, which is the thing in the hash marks, it's going to automatically escape any of the single quotes in those expressions. So underneath, when you're looking at the Java, you'll see escape single quotes around the variable expression. And the developer doesn't have to do anything to make that happen. It just happens. So basically, there's not a good way, or there's not any way that I'm aware of right now, to escape out of those single quotes because of that function being called. However, the page ID expression is still injectable because it's not quoted. So despite the fact that the ColdFusion runtime is calling escape single quotes around it, there actually are no single quotes to escape from. So you can just do your normal, put in a number and then a space, union select, or whatever the case may be, whatever you want your attack string to be. And the way that they provide to protect against this is to use CF query param. It's kind of like prepared statements in other languages, but not really. But it basically does the syntax check against the expression to make sure that it's in a certain format. So in this case, making sure that page ID is an integer and before actually running it. So the pen testing tip to take out of this is whenever you're looking at a ColdFusion page and you're looking for a SQL injection point, always look for a numeric parameter, because if it's a quoted parameter, if it's a string parameter, which obviously has to be quoted, you're not going to be able to inject in it because of the automatic single quoting that escape single quotes that ColdFusion does. So look for the numeric parameters, and those are almost always going to be injectable unless the person put quotes around them in the query, which they usually don't do. We're not going to spend a lot of time looking at the other common vulnerabilities in web applications because I want to spend time talking about classes of vulnerabilities that are unique to ColdFusion. But suffice it to say that it's a web application platform. Any vulnerability that's in the OWASP top 10 or any popular web vulnerability is going to be possible in ColdFusion. You can make the same mistakes. It'll look different in code, but you can make all the same mistakes. ColdFusion has a lot of dangerous tags that can enable this. It makes it a little bit easier for people to make mistakes, making it easy for them to access the file system or the registry, not have to write a lot of code to accomplish that, to just put it in a tag. So it's maybe more likely that people will do dangerous things, but there's nothing really unique about what the vulnerabilities, how the vulnerabilities manifest themselves in ColdFusion. So we're not going to talk a lot about that. So earlier we were talking about ColdFusion components and the idea that you can have functions that are accessible remotely, and I wanted to show you what that looked like. So foo.cfc is a ColdFusion component that we have on the server, and basically any method in that CFC file is a potential entry point if it's defined the right way. So the example URL up there says, we'll load a method called xyzzy in foo.cfc and then pass it these two arguments. And as you can see, it's just all done on the query string there. You can also pass the arguments in the post body as opposed to the get, but the method name actually has to be in the get. Flexibility, I guess. And then there are various things that happen if the method doesn't exist or if the method's not specified. And it goes into some of those error handling methods or on-missing method that's going to be in application.cfc. What to look for here is in any CFC, if you're doing a code review or if you're writing a CFC, you have to define the function using the CF function tag. And at the bottom there you can see access equals remote. If you're setting this thing up to be a web service, you have to set it to access remote because it has to be accessed over the web remotely. But if you're just setting up the function such that it's going to be called by another ColdFusion page, it doesn't need to be remote. Right? You can leave that attribute off, and by default it'll be set to public, which means other pages can access it, but it can't be accessed remotely. Sometimes people will turn on access remote for testing purposes and not turn it off. Sometimes they'll misinterpret what remote actually means, so they'll think that it has to be remote for another page to call it. So there's common developer mistakes. You can't really fault ColdFusion for this, for stupid mistakes. But watch for that attribute. So if you say access remote, then it's something that can be called remotely, especially if it's something that's sensitive, that's only intended to be called by other pages, and you can call it directly, like changing somebody's permissions or accessing part of an application that you shouldn't otherwise be able to access. That would be dangerous. Okay, getting back to variable scopes, and it gets a little confusing here, but before we talked about all the different variable scopes that exist within ColdFusion, and that you can call them by explicitly specifying the scope. For example, cookie.something will look in the cookie scope only. But what happens if you specify a variable without a scope? What happens in that case? Again, remember the overarching theme here, which is ColdFusion was designed to be easy to use. So they don't want to throw an error message when that occurs because that makes it more difficult to use. So what happens if you specify a ColdFusion expression such as like hash foo hash without a scope, it's going to go through a search order. And it's going to go through a bunch of different scopes in order looking for a variable called foo. And if it finds one, it'll use it. If it doesn't find one, it'll move on to the next scope. There are actually 12 scopes that it searches through. These are the ones that are probably the most relevant. So they're in the proper relative order, but there are some other ones that are sprinkled throughout there. Like if you're inside a query loop, for example, that falls into earlier on in the scope. But these are kind of the important ones because they're the ones that are like CGI, URL, form, cookie client. Those are the ones that are most often tainted. So, for example, kind of a side effect of this search order is that if you have an application that doesn't specifically use scoping, you can almost always override form parameters with get parameters because the search order will look at the get parameter first. It'll, URL is number 3, form is number 4. So if it reaches, if it sees a variable by the same name in both scopes, it's going to hit the URL one first. Question?
Do you know where the request falls in this list?
I don't know offhand. Not all scopes are included in the search order, so some scopes actually do have to be specified explicitly, and they will never be searched.
I'm not sure request is in there.
Yeah, I don't think it is either. If you, in the white paper, we have a link to the part of the documentation that has like all 12 that are searched. We just didn't fit them all on here. But yeah, some scopes do have to be specified explicitly, and they'll never be just like automatically searched. So one thing that you should do if you're developing an application, or if you have access to the code for an application that you're reviewing, is just look for any scoping inconsistencies. So what I mean by that is, number one, any case where unscoped variables are used, but more importantly, any case where there's a mismatch between places where scoping is used and is not used. So if they write a variable, if they set a variable using a scope, and then they read that same variable later without a scope, that's a potential attack point, because they're making an assumption at the point of the read that it's going to be reading only the variable that they set. But in reality, it may actually be reading a different variable that the user can control. We have a few examples of that coming up. Okay, this is a really, really simple contrived example. Most of these examples are pretty contrived for the sake of fitting on the slide. But here's a case where, let's say the application has a variable called important var, and earlier on in the application somewhere, some logic was executed, and if a certain set of conditions were met, it set the variable called important var. And then later, we have this code, which checks to see if that variable is present. And if it is present, they're making the assumption, right, that it was set by the application itself earlier on, after whatever logical check that it made. So it says, if defined important var, then go ahead and do this important stuff. Otherwise, print an error message that says you're not allowed to access the functionality. So they're making an assumption here that if they see a variable called important var, then the application must have created it. But that's not true, because of the fact that they didn't use scoping. So if I just put important var equals anything in the URL, or the post body, or a cookie, or basically anything in the search order that I control, that check for is defined is going to come back true, and it's going to execute the do important stuff function. The application developer doesn't realize that that's happening, because they think that it's only going to be defined if they defined it. So that's one danger of doing that. If they had done is defined variables dot important var, then it would have only checked the variable scope, and it wouldn't have checked any of the other user-controlled scopes. Here's another one. So you have the logic up at the top of the page to process the user login. So it says it authenticates the user, checks the username and password, and it also calls a function called isAdministrator on the username to figure out whether the user is an admin. So basically, if they authenticate and they're an admin, then it sets a variable using cfset called client.admin, and it sets it to true. Otherwise, it sets client.admin to false. So far, so good. And that's the type of code that might be in an application.cfm page, something that gets called before every page in the application, right? Commonly used for access controls and things like that. Now, later in the application, you have other pages that then go in back and check that admin variable and make sure that it's true before allowing the user to do any restricted things. So there's a potential check that might be carried out later in the program. CF if admin equals true, and it checks to see if variable admin is called true, is set to true. You've probably already figured out by now that the mismatch there is that you're setting it with client.admin, but you're reading it with an unscoped variable. So it's not going to look at just client.admin, it's going to go through that search order. And if I put admin equals true in the URL, it's going to hit that URL scope before it gets down to the client scope. If you remember, client scope is number 6. Right? So if I have any variable that's called admin earlier on in the search order than the client scope, then the application is going to use that one instead. And that's why I can just put admin equals true in the URL, and it will bypass that check. And I could put admin equals true anywhere in the search order. So again, it's a really easy thing to look for. I'm just looking for the fact that I'm setting client.admin, but I'm just reading admin. Really easy to find. Really common mistake, but easy to search for. Undefined variables are another case, sort of related to unscoped variables, but kind of related to the fact that there are similar tags in ColdFusion that you might think do the same thing, but they don't. And the two of these that are most often confused are cfparam and cfset. Cfparam basically looks for a variable and figures out if it's not already set. And if it's not already set, then it will assign a value. cfset will always make an assignment regardless of whether or not there's already a value there. So we have an example of some, again, a contrived code snippet. Let's say you have cfparam, name equals pagenum, default equals 1. What that's going to do is it's going to say, well, if pagenum is not already defined, then assign it the value 1. And then you have a cf output tag that prints some stuff on the page. It says, now showing page 1. Easy, right? Well, the developer may be assuming that the value is always going to be 1 unless it's unless they've already set it to something else. But basically, it's going to be exploitable in scenarios where, again, you put a variable called pagenum in the URL or the post body or in a scope that you control. Because what's going to happen is the cfparam is going to execute, and then it's going to say, oh, well, pagenum already exists. Pagenum already contains, script, alert, whatever. And it's not going to assign the value 1. So this is really more of a confusion between what different tags do. Environment variables, you have a CGI scope that we talked about before. And this is similar to other CGI scopes in different application development platforms, except that in ColdFusion, you can actually manipulate a whole lot more than you can in other platforms. So normally, you can alter CGI.queryString or CGI.host. In ColdFusion, you can manipulate almost everything in the CGI scope. So for example, CGI.httphost in a normal request is going to contain whatever's in the host header. But if you provide a host header and an HTTP header that's actually called HTTP host, that will override the value of CGI HTTP host, and it will actually contain in the lower code snippet there, evil.com instead of example.com. I have no idea why it does that, why they allow you to do that. There appears to be no defensible reason for allowing you to overwrite CGI variables, but there you have it. You can actually create any HTTP header, so it can be HTTP header called foo, and that will create a variable in the CGI scope called cgi.foo. Nobody knows why. More dangerously, you can override things that in other application development platforms you can never override. You can, if you have a ASP.NET or Java page, you can never override server software or path info or some of these other things that are generally defined on the server side and considered immutable. And there are a lot that you can actually override just by using an HTTP header. You can override CGI.authUser, which doesn't seem like something you should be able to override, but yet you can. If you're deploying this in a situation where you're using basic auth or NTLM auth and the actual authenticated username is stored in a CGI variable, you want to make sure not to use auth user. You want to make sure to use remote user. It'll be populated the same way for either one, but remote user is not overridable, and auth user is. Again, no idea why. And then finally, before we get into the Java stuff, persistence issues. We talked about the client scope before and the fact that you could configure that to be using the registry or the cookies. And essentially, if they have it defined, or if you have client management enabled and you have client variables set to use cookies, then tampering is always going to be possible. Just you can poison any cookie. That's a well-known fact. But oftentimes, the developer will just say, "Well, I'm using client scope variables to persist data across multiple visits to the site." They may not actually know how that works, right? It's a black magic a lot of the time, but it's actually in a cookie. So if you put something sensitive in a client scope variable and you're not realizing as a developer that it's in the cookie, then that may open up the application to some really, really simple cookie poisoning attacks. The cookie that's used for the client scope variables is not encrypted in any way. There's no MAC, there's no HMAC. Everything is in plain text. It's delimited by, I forget, but there's basically a name-value pair with delimiters, and it can be manipulated in whatever way you want. Again, the remaining part of the talk, we'll look at what ColdFusion looks underneath, and I think we have about 10 minutes left.
So as we talked about earlier, right now, as of ColdFusion 6 or MX, ColdFusion is now Java-based. Everything is compiled to every page, every component is compiled to Java classes, and then run inside the context of servlets. Now, CF or ColdFusion lets you compile. You can precompile pages in addition to having them run at runtime. Most of the time, you don't need to do this because they still want to make it easy to use, and so you can still, deploy your site live with the plain source CFM and CSV files, and have those be editable, and changes get detected and recompiled on the fly. You can precompile if you'd like to speed things up a little bit. And so for each class, for each file, it generates one class per page or component. And then in addition, any functions, any UDFs defined in that page or function also get their own classes. And ColdFusion comes with a utility called CFCompile, which does the precompilation if you want. If you have more than one class that gets generated for a given file, it doesn't generate multiple files. It generates one. It concatenates all the related Java classes related to a given source file, and it puts them into one concatenated file, and the file name is identical to the source file. I suppose it made sense to somebody, but that isn't that's not necessarily easily analyzed. You kind of have to separate them. And also, you can take those files and then bundle them up as an EAR or WAR file and shove them into your application server of choice. So as I mentioned, they use a fairly non-standard format for bundling up classes instead of using a jar or multiple files. So we wrote a quick utility to undo this, and it says as of now, but I haven't gotten around to adding that yet. But I promise to have it up by the end of the night. And it's a free open source Java utility that unpacks all of these compiled files. So if you run across files that have been precompiled with the cfcompile.bat or .sh, you can use this tool to go through and generate individual files, which then you can load into either Pro or anything you'd like, or JAD or JD GUI, and use that. So the way these work is, the way these classes work in ColdFusion is that generally there's one function that is the entry point. For pages and components, that method is called runPage. For UDF method, it's named runFunction. And occasionally when I say they, I mean the compiler factors out certain blocks of code, of generated code, and creates separate methods that are then called by these given methods. And additionally, there are other methods inside of a class and part of the interface that get called as set various data and retrieve and accessor methods for various things. So because you can use, because the variable names are accessible dynamically in a way that's not really possible in Java outside of reflection, the generated Java is actually kind of ugly sometimes. When it comes to variables, you can see we have a simple piece of code over here that just sets a variable named vfoo to value 1. And there's a similar assignment using, well, if it's not assigned already, as Chris mentioned, pbar will be assigned to value 2. And then those values are printed out. This is what it looks like with a lot of setup stuff omitted where the comment lines are. This is what it looks like. In some cases, it generates actual properties of the generated Java class. In this case, vfoo and pbar. And it assigns those. Those represent not the actual variables themselves, but they represent bindings to the current scope of the variable, either the local scope or the scope of the calling page, which is also accessible, or other scopes as well. And because they represent bindings, you can bindings in the table, you can use these accessor objects to set values, and that's what it looks like from when you have very simple static assignments like this. Thought I had a slide that said it, but so when there are static references like this, but that's not the only case. As I mentioned earlier, you can specify the name of a variable to set dynamically, and so I think I have a slide later that shows that. And so here's in this this is the kind of the setup to how those get bound. Those variable scope and local scope objects are basically tables. They represent all of the variables in a given scope and provide the, and here's the setup for method that binds them. Here we are. Now here's the dynamic references. There you can access variables in scopes not only through the bound and generated object methods, but you can also do it through a whole host of methods, and there's a bigger list in the paper, a whole host of methods that basically use dynamic strings as names of variables to read and write. So in this case, you have, So there are other ways to set variables other than cfset, cfparam. gfquery, we mentioned earlier, results in variables being imported into the local scope. Structures, which are structures can act in similar to scopes in that they have properties, and you can set variables to them. That's also true of components as well. Components have their own object associated with them, and other various utilities or other various utility tags. And as I mentioned earlier, you can bundle these applications up as a WAR file, and they're handled by various servlets. The structure is actually quite complicated. They're definitely not just raw JSP pages or raw servlets. There's one servlet that handles all of a given set of CFMs and all of a given set of CFCs. And that sets up all the data for the function, results in the application.cfm being invoked or CFC being invoked if they exist. And included in the WAR is, in addition to these servlets, is the administrator thing. And this is the administrator is a console that administrators can use to set up things like data sources and various request parameters, some of the filtering options. A lot of that is accessible through this web app. And you can optionally include it in the WAR file. It gives you the option. And even if you don't, if you check no, a lot of that is still there, and that's still mapped in the default WAR. So be on the lookout for that. If you are overseeing people who are deploying using this, you might want to, after these WARs get generated, you might want to unpack it and take out some of the things that aren't in use if you're not going to use this administrator. One interesting thing about this is that the administrator has password protection, but there is no way to reset the password or retrieve it from files. So if you lose the password, the way Adobe tells you to get it back is to go into the XML file, neosecurity.xml, and just turn off authentication altogether. That's great, except if you forget to do that, then it just stays off. And you don't really notice because there's pretty long-lasting sessions with the ColdFusion administrator anyway. There's a bunch of other servlets. There's some that support Flash and a bunch of other things. There's JSPs. There's support for running actual JSPs, I should say. There's Flex integration. There's some graph support and other things. We can skip through this. So I guess we're going to have some final thoughts. Does anybody have any questions first?
This is the last slide.
OK, great.
So there's conclusions to take away. And in the paper, we actually have takeaways for different audiences. So we have takeaways for developers, takeaways for pen testers, and takeaways for Adobe in the white paper. But this is just kind of an overarching thing. So ColdFusion was designed to be easy, but the cost of making it easy is that it actually is very complicated underneath, and there are unexpected things that happen, like the variable scoping. Easy to make mistakes if you don't really understand how ColdFusion works with the request lifecycle, how error handling is happening, the default error pages and things like that, how variable scopes work, how the search order works. All these things, just by looking at the ColdFusion code, you have to understand how that works. Otherwise, you don't really know if there are vulnerabilities there. A lot of features in ColdFusion, quote-unquote features that are useful for debugging purposes, but open up holes because they increase the attack surface of the application, and those things should be minimized just like in any other application that gets deployed to production. ColdFusion generated Java classes are pretty ugly. If you've ever looked at JSP compiled down to Java, it's similar. It's just like, it blows up, it explodes like 10 times the original size because of all the ugliness that happens there. And then, if you come across a war or error or compiled class files in a server, when you're doing a pen test, you need to reverse engineer. Use our tool CFexplode to break them down into class files that you can then feed into JAD. And then, just generally, there's a lot of stuff there when you deploy an application. If you take like a single-page ColdFusion application, and then you just use all the defaults and you say build a war, you'll get like a 120 meg war file. It has all these servlet mappings and all the CF administrator and all these things turned on. So always strip out unnecessary components before deploying an application, and verify that they actually were stripped out before you put it out there. Here's our contact information. We have a blog, Veracode, where we sometimes write stuff. The white paper and presentation will be on the website, as well as probably the Blackhat website. The CFexplode tool is there on Google Code, and there's contact info for us if you want to ask anything afterwards.